Hi everyone! We're going to review why fasterisprime is actually faster than isprime. So let's look at these examples. So here we have isprime, and we have our factor checker going up from 2 all the way to n not inclusive. So we're checking pretty much almost every single number that is smaller than n. And so the big O of this isprime function is actually O of n. And we can see that it took about 517 milliseconds. However, fasterisprime only goes up to the square root of the number that we're checking, and that's a huge difference. We're checking not anywhere near as many factors because the square root of a number is significantly smaller than the actual number. So this is big O of the square root of n, where n is the number that we're checking to see if it's prime. And the reason that we can do this, I'll remind you, is that because factors come in pairs, when we check one factor, we're effectively checking its partner factor. So for example, 16 has the factors 1 and 16, 2 and 8, and 4 and 4. And we check and see if 2 is a factor, we're also checking and seeing if 8 is a factor, for example. So there's no reason to check it twice. We can just go up to the square root of the number. And so we see that this was much faster. Isprime, when we only go up to the square root, completes in 161 milliseconds. And so we can check and make sure that it's faster. And we're going to actually import time and time these two functions and kind of race them against each other. So let's see what happens. So they work the same, but we see once again the isprime took 94 milliseconds, but fasterisprime took 6. So we can see there's a huge difference.